right, today we are going to be talking about complex numbers. In our learning targets for today, we're going to perform operations with complex numbers and work in the complex number systems when solving equations. All right. Remember, complex numbers are two parts. They're one part real and one part imaginary. Okay. You'll see the standard form. We'll talk about standard form in a minute, in a little bit. But this part here would be our imaginary number. Remember, imaginary numbers contain I, all right? I, which is the square root of -1. Okay, it's not imaginary like La La Land imaginary, but imaginary in the terms of I, okay? We'll talk about this part in a minute, but remember from first semester when we talked about natural numbers, and then whole numbers are natural numbers, including 0. Integers are inclusive of whole numbers and natural numbers, which we add negative numbers. Rational numbers are numbers that can be written as fractions, including positive and negative. Okay, irrationals have non-repeating decimals. Okay, square roots, numbers that cannot be written as fractions, and real numbers are all-encompassing. Now we have also these imaginary numbers, which are numbers including I, which are separate from our real numbers. Okay, imaginary numbers have real numbers in them. 3 is a real number, right? Well, complex numbers contain both. Complex numbers contain real numbers and imaginary numbers. All right, they contain both. Okay, it's a combination of the two. More rationals are like pi and e as well. Biggest thing we need to remember is that I is equal to the square root of -1, right? In some classes, you may have been taught about this clock, all right, the I clock, where you have I to the first power, I to the second power, I to the third power, and I to the fourth. We know I to the first is just I. I squared is I times I, so root -1 times root -1 to give me -1. I to the third is I squared times I, so negative I. And I to the fourth is just I squared times I squared, so +1. Okay, well, we have this on the last page. I to the first is I squared is -1, I to the third is -I, and I to the fourth is +1. Again, that's I squared times I squared to get -1 times -1, etc., etc. So, when simplifying a problem like this, okay, when we have I to the 26, I can think about it in terms of the clock, all right, or I can think about it in terms of 4, all right. I want to rewrite I to the 26 as a power of 4. So I want to think about how many groups of I to the 4th can I get into 26. Well, I know that 4 times 6 will give me 24. So really, this is I to the 4th to the 6th, and then this is I to the 24th, right? Well, there's 2 left over. So I want to write these in terms of I to the 4th. Why? Because I to the 4th is just 1 times I squared, which is -1, to give me an answer of -1. I to the 137, well, I want to do 137 divided by 4. Gives me some decimal. I think it's 34 point something. Well, I know that 4 to the 34th is 136, or 4 times 34 is 136, so I'll do I to the 4th to the 34th times I to the 1st. Well, this is just 1 times I, which is I. Again, 215 divided by 4. All right, I got 53 with some decimal. So I know I to the 4th to the 53rd will give me 212. So there's 3 left over. So I have I to the 3rd, so it's 1 times I to the 3rd. Well, you can leave it as I to the 3rd, but I to the 3rd is -I. Okay. basically get in terms of 4 and then look at your remainder. All right. So let's talk about standard form of complex numbers. Again, like I said before, it's 1 part real where A is the real number and 1 part imaginary. All right, my imaginary number contains a real number attached to it, or can, all right, but that's still an imaginary number because of the I. Just like polynomials, when adding or subtracting complex numbers, all you do is combine. Okay, that's something else there. Combine like terms. That's terms. Okay, this thing is really making me happy. If multiplying complex numbers, it's just like foiling or distributing. All right, you're going to distribute and then combine your like terms. So distribute, then combine like terms. There, took care of that problem. Right? For sure. All right, so let's try one. Write in standard form. Okay. Again, I want to combine my like terms, so I'm going to distribute this -1. 3 minus 2i minus 2 minus 5i. Combine my like terms. 1 minus 7i. That's it. Simple enough. Next one, multiplying, I want to distribute. So 1 times 2 gives me 2 plus 4i. Or instead of distributing, this is essentially foiling, right? Minus 6i minus 12. I promise you that's a 12. Oh my goodness. Minus 12i squared. All right. Well, I squared, remember, is -1, so this is really -12 times -1, which becomes +12. So I have 2, and this is minus 2i now, plus 12, so 14 minus 2i. And you may be able to skip some of this stuff in your head. So somebody steps in your head, that's totally fine. I just want to write it out for the first time we're seeing it and kind of explain it that way. But that's all right. All right, same idea here. We're going to multiply and combine like terms. Now remember, this is foiling. 1 minus 2i times 1 minus 2i. And then minus 1 plus 1 plus 2i times 1 plus 2i. Alright, well, I'm going to FOIL this part over here. So I got 1 minus 2i minus 2i plus 4i squared. Minus 1 plus 2i plus 2i plus 4i squared. Okay. If I combine, like, remember this is I squared is -1, so really this is minus 4. I squared is -1, so really this is minus 4 here. Alright, and if I just write everything, I'm just going to rewrite everything. 1 minus 2i and combine like terms in a minute. Minus 2i. Okay, now if I go through and distribute this negative, let's say it's in green. This is plus, negative, negative, negative. This ends up being back to positive again because the I squared made it -4. If I distribute the negative, it makes it +4 now. So I have minus 1 minus 2i minus 2i plus 4. I believe I forgot this negative 4 right there. Sorry about that. So I have positive 1, negative 4, negative 1, positive 4. So my constants actually cancel in this one. And all I'm left over is 2, 4, 6, 8, negative 8i. And this is technically standard form. That's like 0 minus 8i. Alright, so it's technically in standard form. Okay. Alright, when multiplying here, I want to take the i's out first. Order of operations says take my i's out first. Whenever you have a square root of a negative 1, take that out right away. And then multiply. I squared root 50. 50 is 25 and 2, so it's I squared is negative 1. So this is negative 5 root 2. Because this is root 25 root 2. Negative 1 times 5 times root 2. Alright, here I want to rationalize my denominator, which means I'm going to multiply the top and the bottom by the conjugate. So go ahead and do that and check your work. Alright, here's my work for that one. I got 12 plus 3 root 2 over 14. Okay. Write in standard form again, just like with radicals, I cannot have an I in my denominator, so I want to multiply by the conjugate, the top and the bottom by the conjugate. So why don't you pause again and try that. After FOILing out, this is what I got. 6 minus 7i plus 12i minus 14i squared. I squared is negative 1, so I made it plus 14. 1 plus 2i minus 2i minus 4i squared. I squared is negative 1, so I made that plus 4. So I had in my numerator, 6 plus 14 gave me 20. Negative 7 plus 12 gave me 5. All over 1 plus 4 gave me 5. When doing these problems, you want to separate the two, okay, and write it as two separate terms. Now I'm doing this for a reason. In case this was a 3 on the bottom, I would have to write it as 20 over 3 plus 5 over 3. But I know I can simplify this to become 4 plus I. All right. Last one, I want to think of this as two separate quotients, okay? And I want to rationalize each denominator separately before taking care of the minus in the middle here. Okay, what I mean by that is I'm going to multiply by negative I or positive I. I'm just going to choose negative just for the sake of the conjugate, and multiply their second quotient by 4 plus I. 4 plus I. Okay, I'm going to do that, pause it, here we go. So here's where I'm at so far. Negative I minus I squared, minus I squared, and then over I squared minus 12 plus 3i, and if I FOIL this out, I got here, okay, I squared became 1, or excuse me, negative I squared became positive 1. Alright, so I'm going to change my i's here, my negative I squareds, into negative 1. Alright, so this negative I squared became plus 1. Negative I squared on the bottom became positive 1. So I distributed my negative here and wrote it as two separate terms. So I have negative I plus 1 minus 12 over 17 minus 3i over 17. Well, really, remember, this is just, I would need some common denominators here. Negative 17i over 17 plus 17 over 17 there. So minus 12 over 17 minus 3i over, that's a 3, obviously. Come on to 17. 3. Oh my goodness. That's a 3. That is a 3. We're just going to say that's a 3. Alright, so combined our like terms here. Okay. So you should end up with, what do I end up with? 5 over 17. Because I have 17 minus 12. And then I have negative 17 and negative 3 to give me negative 20i over 17. You could have, at the beginning, you could have found a common denominator and then done all of your work, but I find it easier to clear my denominators first. All right. Those are complex numbers. The last section and last video of Unit 7. It's been real. It's been fun. real fun.